Hi, I'm Dr. Daniel Korkos, and this is a presentation on the cancer risk related to X-ray medical imaging, and particularly to screening mammography. There will be three parts in this presentation. First, what is currently known about the cancer risk related to X-rays? Second, how do we conclude that there is an alarming rate of mammography-induced cancers? And third, why and how has the risk related to X-ray imaging been minimized? X-rays are known carcinogens. This effect is mainly due to the creation of double-strand DNA breaks, which remain unrepaired or incorrectly repaired. Randomly, one cell will have a DNA damage affecting a gene regulating the control of cell proliferation, and the uncontrolled growth of such cell will lead to a cancer after several years. To counteract the DNA damage created by X-rays, we have enzymes able to repair double-strand DNA damage, but some of them are absent in cells of certain individuals. I will not discuss in detail all this information, which you can find everywhere, to concentrate on the important point. How high is the risk of cancer after medical imaging? At the beginning of imaging, the first undesirable effects that were observed were burns, as in this picture. Burns occur rapidly after irradiation, so there was no controversy on whether they were related to radiation. Although the cancer related to radiation was first described in 1902, there were only 200 cancer cases in the literature as of the early 50s that were attributed to radiation. This can be easily understood because cancers occur with a long delay, usually many years, and the role of radiation is often impossible to determine. However, it was known soon that X-rays were causing mutations, and it was realized thereafter that somatic mutations were at the root of cancer. To have an idea of the risk related to the radiation dose, scientists used the observations made in Japan after the atomic bombing. The dose of irradiation received was an inverse function of the distance from the hypocenter. Therefore, it was possible to have an idea of the dose-response relationship for cancer risk. Although it was clear that radiation increased cancer risk, there was a large uncertainty on the type of dose-response relationship from the data, because there were small numbers of people for each dose and large confidence intervals for each finite dose. From prior reports, the dose-response relationship could be anywhere between these two curves, where you can see the dose on the horizontal axis and the relative cancer risk on the vertical axis. The gap between the two curves is due to the large confidence intervals corresponding to each dose. It can be tempting to draw a linear relationship, like in the linear no-threshold model, but you could also draw a curve with a threshold, where there is no increased risk until a certain minimum dose, or a supralinear relationship in which the lowest doses have the greatest incremental risk. There were proponents for each possibility, and the linear no-threshold model had most of the supports. Despite all the uncertainties, it is largely believed that one can safely estimate the risk of cancers from low doses by extrapolating from the dose-response curves generated from the higher doses. More recently, there have been numerous studies on DNA damage in cells. Many of these studies suggest that cells could be more sensitive at low doses of radiation in a supralinear fashion. As a conclusion of this part of the presentation, the supposition that there is a very low risk from low doses of radiation remains an estimate with high uncertainty. The risk of cancer is lower than one cancer for 100 X-ray imaging procedures, and these cancers occur long after the radiological examination. The possibility of evaluating the effect of radiological examination has been permitted by mammography screening programs. The discovery of mammography-induced cancers was triggered by the puzzling evidence that there were very few benefits from screening mammography. The next presentations will be on the accumulating evidence for a very high rate of mammography-induced cancers.